Hello everyone, this video covers section 9.4. This will be the last table we need for the semester. It's called the F table. And we're gonna do inferences that is related to two standard deviations. If you notice in 9.1, it was two means. In 9.2, it was two proportions. In 9.3, it was again two means, but these were dependent, while these were independent samples. So in section 9.4, we're going to have two standard deviations or two variances. But before we go there, which this is what we're doing, you need to learn how to read the F table. The notation for the table is the following: alpha over 2, since it's two tails. And then we're going to have degrees of freedom for the numerator and degrees of freedom for the denominator. So now you have 2 degrees of freedom instead of just 1. So here, this assumes that alpha was 0.05. You divide by 2, you get 0.025. The degrees of freedom for the numerator and the denominator is going to be n1 minus 1 and n2 minus 1, or n2 minus 1 and n1 minus 1, depending on one small thing that I will tell you in the next page. But for now, let's just learn how to read the table. Again, this is alpha over 2. This is the degrees of freedom for the numerator, and this is the denominator. The table looks like this. There is actually 2 pages for this, and unfortunately I think I only imported 1 page, so we'll have to stick to this one for now. Okay, but this is how the table looks. The numerator is gonna go left to right, and the denominator is gonna go up and down. And then these are the values for alpha. So this is very, very similar to t and chi-square, except that now you need 2 degrees of freedom, numerator and denominator. So for example, for the first part, it's telling you that the numerator is a and the denominator is 7 and alpha is 0.025. So therefore, the numerator here is a, which will be this. The denominator is 7, which will give you this one. And then you have to go with the one that has 0.025, which is this. So the value where they intersect is 4.90. So therefore, the value for this one will be 4.90. Remember, the whole point of this is to find the rejection region. This is technically F, the right side. Remember, the chi-square have a left and a right side. We cannot find the right side with the table, so we had to just be happy with the right side. The shape is very similar. So the whole point of this is to find these values, because this is going to be the rejection region. So this will be the rejection region, and this will be the fail to reject. As you can see, that's very, very easy, but you didn't get that one. Here's the last chance to redeem your sins. So look to the next problem. Here, the numerator now is 12 degrees of freedom. The denominator is 3, and the value for alpha over 2 is 0.01. So in our particular case, then 12 is here, 3 is here, and since you want 0.01, Then look to this one, and the value where they intersect is 27.05. So therefore this value is 27.05. Okay, 27.05, which is right here. And again, the whole point of this is we're going to use these values as the rejection region. So this will be the right side. So you have 27.05 here. This will be the rejection region. And this will be the fail to reject. So as you can see, this is pretty easy to find. Now to find this one, the 13 is in the second page, which I don't have. I should try that by yourself, but we can do this one. So now the degrees of freedom for the numerator is 25. As you can see, 25 is not here, so 25 should be somewhere here. Well, the closest thing to 25 is obviously 24, and then the other number we want is 6. So therefore now we have to look to this one, 25 and 6. If the degrees of freedom are not on the table, all you have to do is write whatever is the closest one. So in this case, all you have to do is say this is 0.05. We're going to use 24 because 25 is not there. And then we have 6, which the value is equals to 3.84. All right, so you have 24, which is this one. 6 is in here, and then you're looking for 0.05. So the only part where they intersect is this one, which is 3.84. All right, so now that you know how to read the table, then you can do the hypothesis testing. The setup is the same as before. The claim is that there is no difference between the two standard deviations or the two variances. The alternative is that there is a difference. Then you find the test statistic, which is, this is probably the easiest one to find, is this variance. Make sure you use the variance regardless of whether these are a square or not. Now, the part you have to be very careful here is that the formula says S1 over S2. That's not quite right. And if you do S2 over S1, that's also not quite right. So therefore, how do you determine? Well, you do it this way, and it's very, very important. This is actually the most important thing. If you get these two mixed up, the whole thing is going to be wrong. So for example, let's say that you have N1 is equals to 6 and S1 is equals to 10. And let's say that N2 is 8 and S2 is equals to 16. So the way you're going to determine is you're going to look to the biggest S, or the biggest standard deviation, and that's the one that's going to be in the top. So in this particular case, F star is going to be 16 squared over 10 squared. So pretty much this value always has to be more than 1. That's how you know you're doing this correct. Now, since S2 is now in the numerator, as you can see from here, then the degrees of freedom for the numerator is going to be this one, which is A, minus 1, it will be 7, and the degrees of freedom for the denominator is going to be this one, since this is in the denominator now, minus 1. So this will be 6 minus 1, which is 5. So you have to be very careful. The one that determines which is the numerator is the S, not the N. Okay, let's make sure this is clear. Okay, let's say now you have this case. Let's say that N1 is equals to 20, S1 is equals to 4, N2 is equals to 6, and S2 is equals to 16. Again, you can see the biggest S is S2, so therefore F star is going to be 16 squared over 4 squared. But now the degrees of freedom for the numerator is still going to be this one, 6 minus 1, which will be 5. And the denominator is going to be 19. Okay? Then the rejection region is what I just showed you on the previous page. And the p-value, you can approximate it also or use the table to approximate. You can use the table to approximate it, or you can use a calculator, a TI 83 or 84, to find the value. And then finally, the conclusion and summary is the same as before. Okay? Nothing new here. All right, let's try one example. Consider the following information. Let's say that N1 is A, N2 is 10, the first standard deviation is 20, second standard deviation is 5, and alpha is 0.05. So step one, it should be obvious. We're trying to check if the two standard deviations are the same. The alternative is that they are not the same. Now in step two, we find the test statistic, which in this case, the biggest S is S1. So therefore, this will be 20 squared over 5 squared, which you should check that this is equals to 16. Now, since the biggest S was 20, then the degrees of freedom for the numerator is going to be N1 minus 1, which in this case, it will be A minus 1 or 7. And the degrees of freedom for the denominator is going to be 10 minus 1, which is equals to 9. So therefore, for step 3, for the rejection region, is going to be F of 0.025, remember alpha divided by 2. The degrees of freedom for the numerator, which is 7, and then the denominator, which is 9. So when we look to the table, so if we look to the table, you have 7 for the numerator, which is this one, and then 9 for the denominator, which is all of this. But then you only want 0.025, which will be number 3. So that will be 420. So therefore the rejection region is going to be 420. Remember, this is technically just the right side. So the rejection region is going to be here. This is 420. So any number here should be rejected, and here it will be failed to reject. Here the value for F star was equals to 16, which clearly is in the rejection region. So therefore the conclusion will be to reject HO, which implies that sigma 1 is not equals to sigma 2, which means that there is a difference between the standard deviations. Or the variances. Now for the p-value, you can do the same thing we did in the t-table and chi-square table. You can approximate the values. You just have to be a little careful here. So the p-value, step 1, step 2 are exactly the same. And then for step 3, the p-value is going to be twice the probability that F is greater than F star, which is 16 in our case. Now first let's approximate this. Remember that we have 7 and 9 degrees of freedom. So the number 16 has to be between some of these values, and you can see clearly that 16, if it has to be somewhere here. So this will be F star. And as you can see, if the value was in here, remember we have done this before, you pick something between these two. That's what you did with the t-table. But also, with the t-table, if you were in this extreme, you will pick 0.2, and if you are in this extreme, all you have to do is pick something smaller than this one. And you should write this in your own table. So if you are in this side, then just pick 0.0001. Just add an extra 0. So therefore, the approximation using the table is going to be around 2 times 0.0001, which will be 0.0002. And then just like all the problems we did before, you compare the p-value with alpha. Remember, alpha was 0.05. Clearly, this is less, and less means to reject HO. Or if you have a TI 83 or 84, the p-value is going to be twice the probability that F is greater than 16, so that cannot change. This will be 2 FCDF 16. The upper bound will be 1000. The degrees of freedom for the numerator was 7. The denominator was 9. And if you use the calculator, this should give you, once you multiply times 2, the answer is 4.13 e to the minus 4. Remember what this means. This means 0.000413. So this is more exact than the table, but as you can see, also took a little longer. So the faster could be a little bit easier and faster. And again, if you compare this p-value, clearly it's going to be less than this one, so the conclusion is going to be also to reject. And that's it. Actually, one last thing. One thing you have to be careful when you do these problems is make sure that you compare oranges to oranges, and this is what I mean by that. Here, I told you that S1 is 20 and S2 is 25. Sometimes the problem will tell you, well, S2 squared is 25. So you are comparing, obviously 25 is bigger than 20. However, this is the variance, and this is the standard deviation. If you square this one will be 400, which is still bigger than that. So just watch out for that, because some questions, they're given like this, which is straightforward. But other questions, they give you this and this, just to confuse you pretty much, and to check that you understand the difference between variance and standard deviation. All right, so that's it.